Welcome to the Walton Pi. Today we're talking about transforming functions, how to make one function out of another function using two basic transformations. This is the 7th video in my AP Precalculus series where I go in depth into all the topics that are covered on the AP Precalculus exam so that you can be able to just watch one series of videos to cover all the topics. This is my 7th one and we are talking about transforming functions. So first off, what do they do? Well, back in geometry, you may have learned about three different types of transformations that we can perform on objects. They are translations, where we take an object and just slide it somewhere else. Reflections, where we take an object and we reflect it across a line. So in this image, it's reflected across the vertical axis. And then scalings or dilations, where we take one of the objects and we can either stretch it to become bigger or compress it down to become smaller. Now, there are two main categories of function transformations. These different transformations can create those object transformations that we were just talking about. They are additive transformations, which create the translations of the graphs of functions. So these are going to be sliding the functions around. And then there are multiplicative transformations, which create both the reflections of graphs as well as the scalings or dilations of the graphs. Now, if we begin with the function f of x, additive transformations come in two varieties. We have f of x plus a, where the plus a is outside the parentheses. That is a vertical additive transformation. It is transforming it up and down. Or we have the horizontal additive transformation, where it is f of x plus a, where the plus a is inside the parentheses. That's going to be moving it to the left and to the right. Now, let's talk about the vertical transformation. Relative to the graph of f of x, the graph of f of x plus a, again the plus a outside the parentheses, is going to be a unit above the graph of f of x. This means that if a is negative, then it is absolute value of a units below the graph of f of x. So f of x minus 5, that is the graph of f of x shifted 5 units down. Now, relative to the graph of f of x, the horizontal transformation f of x plus a, with the plus a inside the parentheses, that is a units to the left of f of x. I am emphasizing the word left. This is counterintuitive to so many students. This is one of the most common mistakes that I have seen on my tests that I have written. This is a very, very common mistake that you need to pay attention to, okay? I can't emphasize this enough. It is so tricky for so many students to keep this straight. So f of x plus a is a units to the left of f of x. And then if a is negative, then it is absolute value of a units to the right of the graph of f of x. This is counterintuitive to probably 70% of my students. Keep this straight. It is so tricky for so many students to keep this straight. So really pay attention. F of x plus a is a units to the left of f of x. So let's look at some graphs. This might clear it up. If this is our graph of f of x, the vertical transformation f of x plus 2, where the plus 2 is outside the parentheses, that takes the graph and shifts it up 2 units. Now if I instead look at f of x minus 5, that is going to be 5 units to the right of f of x. Again, this is counterintuitive to so many students. Pay very close attention to this, okay? Now let's talk about our multiplicative transformations. If we start with the function f of x, then we either have a times f of x, which is our vertical multiplicative transformation, or we have f of a times x, where the a times x, that's inside the parentheses, that is our horizontal multiplicative transformation. So relative to the graph of f of x, the vertical transformation a times f of x, that is dilated a times further from the x-axis than the graph of f of x. And then if a is negative, it's also reflected across the x-axis. And then again, this one's going to be counterintuitive to many students. For the horizontal multiplicative transformation, f of a times x, that is compressed by a factor of a units towards the y-axis. Again, counterintuitive to so many students. Pay very close attention to if it's f of a times x, that is a times closer towards the y-axis. And then again, if a is negative, there's a reflection across the y-axis. So let's look at f of x. 2 times f of x, that's the vertical multiplicative transformation. It's stretching everything 2 times further from the horizontal x-axis. So any place it crosses the x-axis, it is still crossing the x-axis. Any place it is above the axis, it is even further away from the axis. And any place where it is below the axis, it is even further away from the axis going down. So this is 2 times f of x. Now, pause the video and figure out what is f of 1/2 times x. Pause the video, try and figure this out. Remember, it's going to be counterintuitive to a lot of you. It is going to compress by a factor of 1/2. So that doesn't mean it's going to be 1/2 as wide. It's compressed by a factor of 1/2. So everything is moving towards the middle 1/2 times it. So that means it's not moving towards the middle at all. It's actually going to be stretched out by a factor of 2. This is f of 1/2 times x. It is stretched out by 1 over 1/2, which is stretched out by a factor of 2. So this is what f of 1/2 x looks like. Again, this is counterintuitive to many of you. So go on to Desmos. I'm leaving a link in the description to Desmos. Go on to Desmos and try this out with different functions. Say f of x equals, put whatever function you want, and start to see what is 2 times f of x, what is f of x plus 3, what is f of 1/2 x, what is f of 3x. Try those on your own. That's basically the best way to be able to get a better intuitive idea as to what's going on. So let's now talk about the domains and ranges of functions. We might have a rational function like f of x equals 1 over x. The domain and range of this function is not all real numbers. Here, the domain is every real number except 0, and the range is all real numbers except 0. But then if we look at the domain of f of x minus 1, that is all real numbers except 1, and then the range is all real numbers except 0. And then if we look at the domain of f of x minus 1, with the minus 1 outside the parentheses this time, here the domain is all real numbers except 0, and the range is all real numbers except minus 1. So the domains and ranges of these function transformations can change from the original function. So pay attention to those and figure out how are those getting moved around, and pay very close attention to what's happening. So let's now talk about how we can combine all of these together. So we can combine all of these transformations to get even more complex transformations. So let's say that this blue function is f of x. Then the green function is f of x plus 4. Remember, f of parenthesis x plus 4 close parenthesis. That plus 4 means it is 4 units to the left. So everything's been shifted that way by 4. But then what we can do is we can then transform that function. So this black function is now 1/2 of our green function, 1/2 of f of x plus 4. So it's a simple transformation from the green function, but this is now a little more complex of a transformation from the blue one. Then we can say, well, what's 1/2 of f of x plus 4 all minus 2? That's 2 units below the black graph, so that's now demonstrated here. But then what would happen if I multiply the x by 2? Well, that's going to compress everything by a factor of 2. And so we end up with this red function. Now, pay very close attention here. This is another spot that a lot of students get tripped up on. It's 2 times the x value, only the x value to compress it in. If I multiply 2 times the entire stuff that's on the inside, 2 times all of x plus 4, that's going to be both a compression and a sliding. That's also a translation at the same time. So be very, very careful with this. It is only multiplying by the x value, none of the pluses that are inside there. So this is one of those things that can be very tricky. Pay very close attention to what you're doing, okay? So I hope this was helpful in understanding it. Again, the best way is to go on to Desmos, which is in the description, to just play around with. So go and do that. But before you do, please like and subscribe. It really helps me out. And if there's other things you'd like to see me make a video on, please leave that in the comment section down below. I hope you have a great rest of your day, and good luck with all of your math.